Last part, last problem. Let's get it. So here we have it. Same scenario. Two sides of a triangle, 6 meters and 8 meters. We're gonna have the same scenario as par day with the angle in between when it's 60 degrees, and we still have the same rate at 2 degrees per second. So we'll use all those same conversions as we had before. So now we want to say at what rate is the area increasing. So we still have these situations right here. That the angle, theta, when we get to pi over 3 radians, we're going to want to know what is the rate in which the area is increasing. And then we also have the fact that it was the change in the angle was 2 degrees per second, but we converted that into pi over 90 radians per second in the previous example. So we have this information already. So now we want to just get into it. At what rate is the area increasing? Now we have two sides and the angle in between. Now if you were a trig student, you should know that pretty quick, but it might be lost in your minds as to how we find the area of a triangle when we don't have a right triangle. Well, if we have all three sides, we could use Heron's formula, but that's not this scenario. But if you have, there's one scenario that works, and it's side angle side. So side, angle, side, the scenario we have right now. And the formula for this, that area is equal to 1/2 AB sine of the angle in between. Typically we call it C. We're going to call it theta for this scenario. At what rate is the area increasing? Well, there's the area formula. I mean, if we want to know in which the rate of the area is increasing, I mean, you got to have the area formula, huh? So there we have it. We have our area formula. And now we can probably just start plugging some stuff in. I've already kind of labeled them. The A is equal to 8. So plug that on in, and then we have that B is equal to 6, and then we have times sine of theta. Cool, let's clean it up a little bit. Half of 8 is 4. 4 times 6 is what, 24? So we have 24 sine of theta. So why don't we go ahead and take a derivative on this sucker? So the change in A with respect to time, times 1 of course, because it's all a chain, is equal to the derivative of 24 sine of theta. That's 24 cosine of theta, but we're going to need to multiply by the change in theta with respect to time. Well, we got the angle. We got this angle. It's given to us up here. The d theta dt. It's given to us right here. Plug it in, and all we have to do is evaluate. So the change in A with respect to time, what the question is asking us for, is equal to 24 times cosine of, and that's going to be our pi over 3. Plugging it in from up above one more time, right from there, times our pi over 90. Now be careful, don't put those two things together. That pi over 3 is in the argument of cosine. So we get to 24 times cosine of pi over 3. Cosine of pi over 3 is just equal to 1/2 times pi over 90. And now just be careful in our cleanup that we don't make any silly numeric errors. So half of 24 is 12. And now we have an even number over an even number. So I think we can call that 6 over 45. But oh shoot, guess what? 45, you divide that by 3, you get a 15. Divide 6, you get a 2. So I think we get 2 pi over 15 is equal to the change in our area with respect to time. But if we're talking about area, back to units. Wait. Area. In your house or your apartment, when you rented it, was it 1,000 square feet or was it just 1,000 feet? Area has to do with 2 dimensions. Lengths will deal with 1 dimension, and volume, we think about it in 3 dimensions. So we just need to find our lengths, which the question asks us in meters. So we're just going to say that is going to be our length, whatever that unit is, squared, meters squared, per the unit of time, which was seconds. And there's our solution.